Welcome to Part 2 of this two-part series of films produced by the SIA and ESIG, outlining the hazards of static electricity in flammable atmospheres. As illustrated in Part 1 of this film, splash filling of flammable liquids should be eliminated by submerging the fill pipe to the bottom of the vessel. It is particularly important that the velocity of the liquid being transferred is controlled, so operations such as gravity filling of IBCs from road vehicles should be avoided. After completing a filling operation, it may be necessary to sample the liquid. A sufficient relaxation time should be allowed for the accumulated electrostatic charge to dissipate. Care must be taken when the receiving tank or container has not been cleaned out and contains flammable vapor. Installing filters far enough upstream of discharge points can avoid problems by providing a sufficient liquid residence time greater than the specified charge relaxation time of the liquid. For dispersing operations, the conductivity of the liquid should be raised before particulates are added. If possible, conductive liquids should be added first. In some cases, anti-static agents can be added to reduce the charge accumulation. Typically, only a few parts per million are required. Assessment of the suitability of such additives with each formulation is advised. If additives are used, they should always be used in tandem with an appropriate earthing and bonding procedure. Inert gas blanketing for vessels and pipes should be considered to minimize the presence of explosive atmospheres in the vapor space. Earthing and bonding is a very effective technique for minimizing the likelihood of an ignition caused by static electricity. Earthing establishes a continuous electrical path to earth and will remove charge rapidly. Conductive equipment is connected to an earthing electrode or to the building earthing system in order to prevent sparking. A bonding system connects conducting equipment together to maintain the same electrical potential. Electrostatic discharges cannot take place between objects that are at the same potential. All conductive objects electrically isolated from earth by insulators such as non-conducting pipes, connections, equipment supports or gaskets should be bonded and suitably earthed. Therefore, selection of the correct connections when transferring flammable liquids is very important. Bonding straps and cables should be durable and have a low resistance of less than 10 ohms. Portable equipment must be earthed back to a known earth reference point or common earthing system using the appropriate flexible cables and clamps. The clamp must make contact with metal surfaces through paint, rust and surface contaminants to achieve a connection of less than 10 ohms. Metal containers must be earthed back to the loading system via earth leads and a suitable earthing clamp that penetrates the paint coating. Ensure that both containers are suitably earthed when decanting from one to another. When earthing and bonding, it is vitally important that the clamp is in place before filling operations commence and removed when filling is complete. Do not attempt to attach a clamp while filling is in progress, as this has the potential to generate a spark. When using metal IBCs, the frame around the tank may not be bonded to the tank via an earthing strap, and therefore both frame and tank need to be earthed separately. Generally, it is recommended that plastic IBCs and drums should not be used for liquids with low flash points, as the plastic surfaces themselves can become charged by brushing against them and any charge buildup in the liquid cannot be removed. Some plastic containers have a special provision for earthing, and the operator must ensure that the container is robust and meets the manufacturer's specifications. When filling or unloading road tankers, the connection to earth should not exceed 10 ohms. In all instances, the earthing clamp must be attached to the vehicle before any operation commences and should not be removed until all operations are complete and there is no presence of vapor. Sampling equipment should be of conductive material and bonded to the tank. Sampling should only take place after the appropriate relaxation time has elapsed. If flammable liquids are handled, static, dissipative, personal protective equipment, particularly footwear, should be worn and tested on a regular basis by all people present. To maintain a high level of static electricity awareness, regular testing of equipment must take place, with results logged. Operators should be trained frequently with reference to the appropriate standards and industry best practice. The fixed part of the earthing system should be tested by a specialist authorized contractor, typically every 12 months. Earth leads and clamps for portable equipment should be tested more frequently depending on the nature of the application. Operators should be vigilant for deterioration of equipment between test periods, such as worn cables or broken clamp teeth. Report any suspected faults prior to further use. It is essential that operators using flammable liquids are aware of the hazard of static electricity. The safety data sheet will specify if flammable vapor air mixtures are likely to be present during handling, so it should be assumed that static electricity could be a problem even for liquids with higher conductivities, but can accumulate a high level of charge, such as acetates. This can be confirmed by contacting the supplier for further technical support. There should be reference to the various European and international standards when installing and maintaining a static electricity protection system. References can be found in standards and codes of practice, whether these be specific to static electricity or for handling flammable liquids or operating in hazardous atmospheres. Consult your local health and safety regulators and specialist authorized contractors for further advice. Over the course of these 2 short films, we have seen how a familiar phenomenon can be a serious hazard, but we have shown how this hazard can be eliminated through good operating practice and use of earthing and bonding equipment. Solvents have a vital part to play in industry and enable us to have the products and resources that are fundamental to our daily lives, but are safe if handled correctly. The solvents industry is well regulated, and there is information and advice to ensure the risk associated with the hazard of static electricity can be minimized or even eliminated. Thank you for watching this short presentation, and if you need more information, please contact our comprehensive websites.